Everybody we with is tailored. What are we talking about? We're trying to find a Taylor series for f of x is sine x centered at a is pi over 2. And we're looking for a Taylor series. What's that look like? Zip it up, just like that. It's the derivatives evaluated at the center divided by n factorial x minus a to the n. Then we need to go and we need to get derivatives. The derivative of sine is cosine. Well, that's here. The derivative of cosine is minus sine. The derivative of minus sine is minus cosine. The derivative of minus cosine is sine. But then I see it's going to repeat. Now what do I need to do? I need to take all of those and I need to evaluate them. I need to take them and I need to evaluate them. All right, so we go and we evaluate everything at the center. And f of pi over 2 is 1, because the sine of pi over 2 is 1. The cosine evaluated of pi over 2 is 0. The sine is minus 1 when you got the minus outside. The cosine is 0 again. And I think that we have enough to trot out some terms. We're going to trot out some terms to see if we can find the general term for this Taylor. So if I expand out my Taylor series, the one in blue over there in the right-hand side, I'm just trotting out those terms so that I can see the derivative, so that I can plug it in places where they need to go. So 4 terms for now is good, because they want us to find the first 4 non-zero terms. So that's 1 plus 0, and then, okay, so notice what I'm doing. Notice what I'm doing. I'm putting these values in here, 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 here. Good times. Now keep on rolling. They hating. Try to catch us right and dirty. Whatever. So I put that extra term in there just because we lost a couple of the terms due to zeros. We lost a couple of the terms due to the zeros. And I wanted the first 4 non-zero terms so I could see my pattern. So then I'm going to take it to the top. We see it's alternating. It's alternating positive, negative, positive, negative. So I need to decide whether or not that's going to be to the n power or the n minus 1 power. But since my first term is positive and my series starts at 0, my first minus 1 is to the nth power. Now we've lost all those zeros, but we see that we do have the even numbers left over. The evens, the evens, the evens, the evens, the evens, the evens. Yeah, what is that? 21 pilots, all my friends are evens? We'll just let it go. So what? To write an even number, that's 2n factorial, and then I'm going to have the 2n up there. And now what? Now, you need to go find the interval of convergence.